Hi everyone, in this video I'll be talking about the domain name system or DNS for short. So I'll be discussing about the problems or the challenges faced before the domain name system. And after that I'll talk about the general overview of the DNS. So let's get started. Now we all know in networking computers do understand IP address. That is what they do because IP address is the means of identifying every host on a network. But actually, people find it very difficult to remember those IP addresses. So it's a challenge to people. People find it very easier to remember names than remembering numbers. So that is one of the challenges before DNS. So the IP address of a particular host on a network can be changed depending on the configuration or depending on the scenario. So keeping track of all those changes, I mean the IP addresses from this network to that network is a challenge to human. So the first and second problem I talked about here are actually problems that DNS finds solution to. Now let's talk about the DNS proper. So the DNS is basically a system that store the association between an IP address and a domain name. So basically the primary function of it is to match up IP addresses with their domain names. So this system is actually a distributed system in nature in which the administration can be shared among different admins. So basically each admin can be able to keep track of a certain part and which is totally different from what the other admin is doing. Also, because of its distributed nature, the workload can also be shared among different devices or different hosts. So the DNS performance has actually been improved through the replication. So what it means is the replication of content from maybe master to slave is very possible so that the slave can also know what the master knows. And the other improvement is the caching. So basically what this does is it tries to save particular association of an IP address with a domain name the first time the request reaches it so that the subsequent request to that particular host or that particular domain doesn't necessarily need to go out. So it can be served from the cache details earlier. So DNS has this structure, is a tree-like structure, typically like a Unix file system, where you have your root, you have other domains. Now, depending on the requirement of a particular organization, you have different kind of domain. You have a domain with country initials like the UK, the NG, the US, and all that. So you can also have a domain name for an organization, for example, say abc.org. You can also choose to have the .com, which is for commercials, like yahoo.com or google.com and all that. So what actually makes this domain so useful and easy for identification is the fact that it is a unique name, meaning it is globally unique. Just like the case of IP address, where only one computer has a certain IP address, of course, I'm talking about a public IP address, like that, only one domain has that particular name. So, there are certain criteria for domain names. The first one is the characters. So, the character that one can use in naming a particular domain is almost unlimited. You don't have any restriction. Though the maximum is 255 characters in total length, which is more than enough for our requirement, and then the maximum of 63 characters in each part. So reading from this RFC 1034 and RFC 1035 will surely give you a clue on how to do these domain names. So other criteria for naming is the choice of a character. So one can actually use a letter from A to Z and number from 0 to 9. Also, you can you can use minus sign. But the only limitations here is you cannot use underscore in naming a domain. So that is something to take note of. So the DNS can be used in numerous occasions. First is for finding out information. So you can use DNS to get some information about a particular company or particular organization. Now, depending on what you are looking from that particular search or from that particular lookup, you can check different resource record. We'll talk about resource record in a bit, and you can also check for a specific resource record. So, all right. The common resource record are A, which is for address. So basically, this resource record map hostname to IPv4 address and quad A. So the quad A is similar like the first one we talked about. The only difference in this one is that this is for IPv6. So basically, it maps a hostname to IPv6 address. And the PTR, which is pointer. So this map IP address to hostname, just like in reverse lookup. So the MX is the mail exchanger, is a resource record that tells where to deliver mail. And then the other ones are canonical name or the C name. So this one just map alternative hostname to real hostname. So you can actually have a kind of alias to the particular hostname. So we have the TXT is also an example of the resource record. So this is basically any descriptive text. And then the final one here is the NS or the name server. So the name server and the start of authority are used for delegation and management of the DNS. So let's talk about some of the results you might get when querying a resource record or when querying DNS. So the first one here is the positive. Whenever you are querying a particular DNS and the result of that query is one or more resource record, it means that that particular DNS is valid and is active and some of the resource record. And if a result of a query is negative, definitely no resource record will be available. So you not get any resource record from the query. So this is the same case when the server fail or when the query is being refused by the server. Now the DNS is basically a client server application that runs across network. So it uses the UDP port 53 for each request and response, and it occasionally uses the TCP port 53 out very large requests. So whenever the file is larger than 512 bytes, example is the zone transfer from master to slave or an IPv6 quad A record. So that is when the DNS will use the TCP port 53. So DNS has different roles in it. One of the roles is the resolver. So this resolver actually does what it said there. It basically takes requests from an application and format it in UDP form and send it along. So the other role is the caching name server. So what the caching does is it tries to respond with the answer if it was initially cached or saved. Otherwise, it searches for an authoritative server which has the information. So anytime the request is made for the first time, it tries to record that information or try to save the result so that subsequently whenever a client is requesting that same information or that specific information, just serve what has been saved in the cache instead of trying to reach out to the authoritative server all the time. So it is also called the recursive name server. So the other row and the final row that I'm going to talk about here is the authoritative name server. So basically this is the role where the actual information is being saved. So the authoritative name server contains the actual information. Alright, there are several ways in testing out the availability of a particular DNS. One of that method is to use your web browser. So you can simply go to the address bar of your browser and enter, for example, www.google.com or any domain that you are looking for. The other one is to use the NS lookup. So this is a utility that allows you to get some few information from a particular domain. And then the mo- and then the more robust tool is to use dig. So dig allows you to pull a lot of information, more or less like raw data of the domain. That is all I have to discuss for the DNS. I hope you learned something from this video and I'll see you in the next one. Thanks.